Okay. Again, also as a reminder, I did send out a link for office hours. So, if you need to see me during office hours, the link is in your email, or you can go to Blackboard announcements and use the link. Okay. Don't be afraid to email me as well. So this is another example that we did last time, and I thought it'd be good to actually go through it again using proportions. Okay, good. So here, let's say as before, we're walking, we can walk, at a rate of 1.5 miles per hour. Speed walking, whatever. Somehow we're able to do that. The question is, how far can I walk if I walk for 4 hours nonstop? Okay, well, again, we have a rate here, don't we? It's just like last time, we have our rate, which is 1.5 miles per hour, which I'm writing as a fraction. Okay, now from here, right, again, we're walking for 4 hours, okay? We want to know how many miles we're going to hit. So we have this equality we need to solve. I mean, if you want to know, if you're asking, well, how do you know these two have to be equal? Because they both deal with, the speed or the rate at which we're walking, 1.5 miles per hour. So at that same speed, in 4 hours, I walk how many miles? So they both deal with the same thing, so that's why they're equal. Now, so x again is how many miles we're walking, how far we go, our distance. Okay, so let's do that. Again, notice that units are in the same corresponding position. If you're at the top, you go across, you get the same unit. Bottom, go across, you get the same unit. So now that the units are canceled, we have these numbers to deal with. And now what do we do next? We cross multiply. As you can see, we have 1.5 times 4, x times 1. And so we get 6 is x. The left-hand side, by direct calculation, that's just 6. And so I just rewrote x equals 6 instead of 6 equals x, but we end up getting 6 miles. That's what we're getting. Okay. So that's what we get here. So again, it's just using a proportion to solve this. So here's another one. Now we'll do part 2. How long would it take to walk 9 miles? So again, we're going to have the same, we're going to have the same rate from before, right? The 1.5 miles per hour. Now we know we're walking 9 miles. We want to know how long is that going to take us? So the unknown is time with walking 9 miles. So it's just like before. We have two ratios, we get a proportion, and we solve for the unknown. So that's what we're going to do here. Okay. All right, so from here, what do? Well, we can cancel, okay? We cancel, what do you call it, the units, and then we just have to cross multiply. Okay? So from here, we get x times 1.5 is 9 times 1, like so. From here, we get this, right? Because again, we want to get x, so we divide. Okay, we're dividing by 1.5. And so we get x is 9 over 1.5, which turns out to be, if I did this right, 6. I think I did that right. I know before in my other class that there was a mistake, but I fixed it here. So, okay. So this is what we get here. Again, it's just using proportions. That's all we're using here. So our answer then is 6 hours. Okay. All right. Are there any questions about this? Don't type in the chat. I can't see the chat because of the slides. Here we go. Take a look. Now I can. Okay. All right, let me keep going then. Okay, so we can also use proportions to solve unit conversions. I mean, last time what I did, actually maybe the class before that actually, I did unit conversions using the factor label method. So here what I'm going to do is I'm going to use proportions. This is just a table from before, so it's nothing really new. But now we're going to solve these questions using proportions. There we go. Okay, so the first question we want to ask is, how many quarts are there in 35 cups? In other words, we want to fill in the blank here in this equation. Now, what's really nice about using proportions is, before you had to figure out which unit conversion which are the conversion factors you have to use. Do I use this one? Do I use that one? It depended on how the units cancel. With proportions, though, you don't have to worry about that. You can use either one. Namely, it doesn't matter which one you use. We do know that 1 quart is 4 cups, so you can use either conversion factor. So I chose the first one kind of randomly, okay? So we have 1 quart over 4 cups. That's the rate we're going to have. Okay, now we don't know how many quarts there are in 35 cups. That's x. So x is how many quarts there are in 35 cups. Okay? And again, they both deal with the number of quarts and the number of cups. So the ratios here are equal. Okay? If 1 quart is 4 cups, we want to know how many quarts there are in 35 cups. They both deal with the number of cups in a quart. So, good. Okay, so again, notice also the units are in the same corresponding positions. So in other words, on top, you have the same units. In the bottom here, you have the same units. So from here, right, the units are gone. And we have this proportion to work with. And just like before, we can cross multiply. We have 35 times 1 is 4 times x, like so. And then we can just divide from here, because we want x all alone. We don't want 4x, we want x. And so we get x. So we get our answer is 35 over 4, which is x, which means x is 8.75. And so there are 8.75 quarts in 35 cups, as you can see. I rounded to 2 decimal places. I don't think you can round it. I don't think there's more decimal places. If there are, normally I would tell you how many to round to. Let me see. Yeah, 8.75. Okay. All right, so that's one example. Here's another one. So now we want to know, how many cups there are in 320 fluid ounces. How many cups are there in 320 fluid ounces? And again, we can use either conversion factor. You have 8 fluid ounces over 1 cup, or you can use the unit conversion factor, where this is flipped. But this one's fine. This one I chose randomly. So we know that 8 fluid ounces give us a cup, equals 1 cup. So we want to know how many cups 320 fluid ounces equals. So again, we have a proportion. And X is how many cups we have, right? X is our unknown. So how do we figure out X? Well, we're going to cross multiply, right? That's what we get. So it's just like before, we cross multiply. Namely, from here, we get 8 times X is 320 times 1. Cross multiply. Cross multiply. So we get this. And we want X, so we divide by 8 down here. And we end up with 40. So in other words, we're going to get 40 cups. So again, it's nothing more than a proportion. That's all this is. Nothing too fancy. Okay. All right. Okay, good. All right, that's good. Are there any questions on this? Okay. All right. Also, remember, we can do conversions between the two different systems, right? You know, we had the metric system. We also had the imperial system. Metric system, imperial system, right? Metric system dealt with things like centimeters, meters, milligrams, that kind of stuff. And we can convert between the systems. And this is how we convert, right? We use these conversions. We use these conversions and these unit conversions. And again, it's nice in that since we have proportions, we only need one unit conversion from each, not both. You know, with that factor label method, we had to figure out which unit conversion do we use. But here with proportions, we don't really have to. We don't have to worry about that. We just need one. So as an example, here's one I want everyone to try now. You know, take about a minute. You know, we want to know how many inches there are in 10 centimeters. Okay? How many inches are there in 10 centimeters? Okay, so I want everyone to try that out now for like take about 2 minutes. So let me just pause the recording.